Today we are going to read about a special topic that is in binomial theorem and which is very important part of JEE. It is known as integral part of binomial, where we have to find the greatest integer value based questions. Now this forms a small portion of binomial theorem, yet it is very important. So today we will be discussing some of the questions and the theory based upon it. So here, what does it mean, the integral part? So in this type of questions generally, what we are going to refer? We are going to refer p plus root q per power n form. मतलब we have to find the integral value, for example, of 2 plus root 3 per power 7. For example, if the question is like this, 2 plus root 3 per power 7, we have to find the greatest integer value of this. So maybe some other type of questions we will proceed and we'll see. So in this type of questions, p plus root q per power n or p minus root q per power n, or maybe vice versa, root p plus q or root p minus q per power n, we will see. Now, so what is the way out? So we'll see certain steps that will be required. Now first, if p plus root q per power n is given, then consider p minus root q per power n is equal to something, is equal to, let's say, some value. Similarly, if p minus root q per power n will be given, so what will you consider? P plus root q per power n as something, okay. I'm writing short form, of course you will understand this. Now consider this, कि if p plus root q per power n will be considered as some integer value and plus some fractional value. Why? For example, if I say 2 plus root 3 per power 5, now 2 has integer value, root 3 is irrational, so obviously when I expand this, it will give me some integer value. For example, if I say 2 plus root 3, what is the value of root 3? It's 1.7 approx. So this value will be 3.7 per power 5. So 3.7 per power 5, if I raise, it will give me some integral value and it will have some of the value of fractional part. So we will generally consider p plus root q per power n as I plus f. Okay, where I stands for integer, I'll stand for integer, f will be for fraction. Now obviously, if this is the case, then I'll say p minus root q per power n will be f dash. Why f dash only? See here, for example, 2 plus root 3, so 2 minus root 3 per power n. Now 2 minus root 3, so root 3 is 1.732, so if I subtract 2 with 1.732, what value will we get? We will get 0.2 something. So obviously when I raise it to power n, it will only give me values which have fractions, so that's why we'll consider this as f dash. Now what is the general notion? The general notion to in these questions is try to remove surds from the expansion. So what is the case? We are required to remove the surds from the expansion. Now how we are gonna do this? Generally, what's the case? If there is p plus root q per power n and p minus root q per power n is given, where n is odd, then what we usually do? We subtract. And if n is even, we add. This is the usual notion. We will see with the questions how this is done. Now, so let's see how do we proceed. For example, if question 1, I'll write. Question 1 says find greatest integral value of root 2 plus 1 per power 7. Now see, this question is of the same type, so but how we are gonna proceed is, so let's see. What did I say? Root 2 plus 1 per power 7 must be considered as what? As having some integral part and some fractional part. Now if this is the case, so root 2 minus 1 per power 7 shall be considered as f dash. Why? I said to you in the steps ki if root p plus q is given or p plus root q is given, so root p minus q or q minus root p shall be considered as another value. So this is equation 1, this is equation 2. Now we know that fractional part always lies from 0 to 1, and root 2 minus 1, since root 2 is what? 1.414 approx minus 1, this value is 0.414 per power 7 will always have some fractional value that will lie from 0 to 1. So f dash always lies from 0 to 1. It will not be equal to 0 ever. Now if we try to expand, what is our objective? The first objective is to clear off the surds. So how do we clear off the surds? We try to expand, and if we expand the first one, so it will be 7c0 root 2 per power 7 plus 7c1 root 2 per power 6, and there will be 1 plus 7c2 root 2 per power 5 and 1 ka square, and this goes on. Similarly for the other one, it will be 7c0 root 2 per power 7 minus 7c1 root 2 per power 6 and plus 7c2 root 2 per power 5, and this goes on. Now it is so obvious that if we, now this is equal to I plus f, and this will be what? F dash. It is so obvious. What we are required to do, we have to remove the surds. So how do we remove the surds? Now if root 2 per power 7, 1 root 2 will be left out, so we need even powers. That is the reason we subtract. And I obviously told you one thing, okay, that if n is odd, what we usually do, we subtract. So here with the subtraction process, what is going to happen? Let's rewrite. So what will be left out? There will be 2 obviously. Now see, this will get cancelled, this will get cancelled, so what will left out? Root 2 per power all the events, so 7c1 root 2 per power 6, 7c3 root 2 per power 4, again 7c5 root 2 per power 2 plus 7c7, and this will be root 2 per power 0. So this value will be equal to I plus f minus f dash. Now check out one thing. I told you कि f is from 0 to 1, f dash is from 0 to 1, so minus of f dash will be from minus 1 to 0. Just change the sign of inequality when it is multiplied by negative sign. So if I add this 2, so what obviously I will get, f minus f dash will be equal to minus 1 to 1. Now see, this has some value. 2, 7c1 is 7, root 2 per power 6 is obviously 8, plus 7c3 can be written as 7 factorial by 3 factorial and 4 factorial. So 7, 5, 6, 4, 4 will get cancelled. How? This will be written as 7, 5, 6 into 4 factorial, and 4 will get cancelled. So 3 is 6, so therefore this will be 35. Now again 35 into root 2 per power 4, that is 4, plus 7c5 is again 7c2, so this will be 7 into 6 by 2 into 2 plus 1. This will be equal to I plus f minus f dash. Now 7 into 8 is 56. So 56 plus 35 into 4 is 140. Again it will be 42 plus 1. So this will be equal to I plus f minus f dash. So this obviously is the equation. Now consider one thing. Here on the LHS all the values are integer. In RHS I is an integer. So f minus f dash, it obviously has to be some integer. Some integer. Why? If it is not an integer, how would LHS be equal to RHS? So if f minus f dash is integer and the value of f minus f dash always lies from -1 to 1, so f minus f dash must be equal to 0. Why? Because there is only one integer lying from -1 to 1 and that is 0. So this will be equal to f is equal to f dash. So this condition we get it from here. Please do remember, in every case whenever we subtract we'll get this value f, the fractional part, will be always equal to f dash. So we'll see the cases later on. Now what is the equation? 140 plus 56, 196, 197, 197 plus 42. So this will be 9 and 13, 239. 239 to 2 is 478. So the value is I plus f minus f dash is equal to 478, and f is equal to f dash, therefore the value is, this value is 0, and hence the integral value is 478. So what was the question asked? The question asked was find greatest integral value of root 2 plus 1 per power 7, which obviously is 478. So we'll see another question. Let's see if it says prove that if n is a positive integer, n is a positive integer, then integral part of 3 plus root 7 per power n is an odd integer. Now this we are required to prove is an odd integer. So how do we proceed? Let's see. Again 3 plus root 7 is given per power n. What we will consider? Some integer plus fractional part. Why? Root 7 has value 2 point something, so 3 plus 2 point something will be 5 point something. 5 point something per power n will obviously keep some integral value plus some fractional part, and this fractional part will always lie from 0 to 1. Now similarly 3 minus root 7 per power n will be equal to f dash, where f dash lies from 0 to 1. Now check out one thing. Again what we are required to do, first let's expand. If I expand the first one, we'll write nc0 3 per power n plus nc1 3 per power n minus 1 root 7 plus nc2 3 per power n minus 2 root 7 ka square, and is so obvious. So here this will be equal to I plus f. Now for the second one it will be nc0 3 to the power n, wherever there was negative sign it will be included here, 3 per power n minus 1 root 7 plus nc2 3 per power n minus 2 root 7 ka square. This is equal to f dash. Now if this is equal to f dash, so therefore the value will be 2. Add it up. If I add it up, so what will get cancelled? The negative sign value will get cancelled. And why we are adding up? The reason being simple, the surds need to be cancelled, because what we are required to find, the integral part. So if we are required to find the integral part, we have to remove the surds. Now so what it will become, 2 nc0 3 per power n plus nc2 3 per power n minus 2 root 7 ka square, plus it goes on. This will be equal to I plus f dash. Again what is the condition? We said f lies from 0 to 1. F dash is obviously from 0 to 1. It is not equal to 0. Why? because 3 minus root 7, where root 7 is 2 point something, so 3 minus 2 point something can never be equal to 0. So therefore f dash lies from 0 to 1. Now what will be the value? This is certainly multiplied by 2. Let's say some value of k. So 2 into k will obviously be even. Now if I add f plus f dash, so we'll get the value as 0 to 2, 0 not included. Now left side is integer, this is integer. Again we have considered I as an integer, so f plus f dash must be integer. So if it must be integer, then what value shall it hold? The value that it shall hold between 0 to 2. So which integer is there from 0 to 2? So there is only one integer, that is 1. Therefore the value is even integer is equal to I plus 1. It obviously means sum even minus 1 will be equal to integer. Now even minus 1 will obviously give you odd number. So this was what we are required to prove, कि if n is a positive integer, then integral part of 3 plus root 7 per power n is an odd integer, where I was the integral part, and we have already proved that I is odd. Next question. So if next question is like that, say if 9 plus root 80 per power n is equal to I plus f, where I is an integer, I is an element of integer, and n is also natural number. This belongs to z plus natural number, f belonging from 0 to 1, then which of the following are true? First, I is an odd integer. Second, I is even, I is an even integer. C, I plus f into 1 minus f shall be equal to 1. D, 1 minus f will be equal to 9 minus root 80 per power n. So which of the following will be true? Now how do we proceed this? What are the things that we are required to prove? And what will be our course of discussion? First, we are required to find what is I, the way we did in the previous question. Again, what is the next thing? There is something I plus f into 1 minus f. We'll see how do we find the value of 1 minus f. Obviously, in this type of question, I have already stated that if 9 plus root 80 per power n is given, this obviously will be equal to some integral part plus fractional part, where the fractional part will lie from 0 to 1 somewhere. And if 9 plus root 80 is given, we'll consider 9 minus root 80 per power n shall be equal to some f dash, where f dash belongs to 0 to 1. Why we have written like this? Root 80 is obviously less than root 81, which is equal to 9. So 9 minus root 80 will be positive. But this value is obviously something 0 point something, and when 0 point something is raised to power n, it will give you the fractional part only. So this is the reason. Now let's try to expand. Now obviously by expansion we must say that this will be nc0 9 per power n plus nc1 9 per power n minus 1 root 80. I am expanding the first one, so this will be equal to I plus f. Again for the second one, nc0 9 per power n minus nc1 9 per power n minus 1 root 80, and this will go on, this will be f dash, this will be f dash. So what we are required to do? We are required to add up. If we add up, we'll get I plus f dash. So this will be 2 nc naught 9 per power n plus nc2 9 per power n minus 2 root 80 ka whole square. And why did we add up? Because we want an equation to be free of surds. So this gives, because root 80 ka square, root 80 per power 4, it will be free from radicals, and hence this is the obvious equation. Now we know f plus f dash will lie from 0 to 2, even from the previous question, or you can deduce this. How? See here. So it says f plus f dash, so 0, and here 1 and 1 is 2, so the value is 0 say 2. So which integer? See here, in this side, left hand side, this will obviously be an even integer. Now this will be integer, so f plus f dash must be integer. So if it must be integer, what value does it hold? It must hold f plus f dash is equal to 1. So even integer minus 1 will obviously be equal to odd. So what was our question? The first question was I is an odd integer. True, I will be an odd integer. So again, okay, I already ticked it before, but yeah, obviously I will be an odd integer now. So if I is an odd, this will not be even. Next, we also know that f plus f dash is equal to 1. So therefore f dash will be equal to what? 1 minus f. Now another thing, we know 9 plus root 80 per power n is equal to I plus f, and f dash is equal to what? 9 minus root 80 per power n. So if I multiply these two, what will we get? 81 minus 80 per power n is equal to I plus f into f dash, and obviously f dash is equal to 1 minus f, so this will be equal to 1 per power n, which is equal to 1. Now again, see here, what is the option? I plus f into 1 minus f is equal to 1, which is true. Now 1 minus f, which was f dash, it was given from the equation itself. This is equal to 9 minus root 80 per power n, so this is also true. So these three options are true. Next, in next series, if I say, for example, a simple question, if I say n is equal to 2 plus root 3 per power 6 is equal to, let's say, I plus f, what you are required to find? You are required to find n into 1 minus f. How you are gonna find it out? Now it's simple. From previous observation, what we know, that let's say n is equal to 2 plus root 3 per power 6 is equal to I plus f. So we'll consider 2 minus root 3 per power 6 is equal to f dash. What we have to find out? We have to find n into 1 minus f. Now from previous discussion, we know f dash, somewhere it came by 1 minus f. Where? See, f dash is equal to 1 minus f. Now basically what they are saying us to find I plus f, which is n, and f dash. It's as simple, we have to multiply these two. So we'll say 4 minus 3 per power 6 is equal to n into 1 minus f, which is equal to 1. That is the solution. Now question came in JEE Mains 2023. So what was the question? The question said, let x is equal to 8 root 13 plus 8 root 3 plus 13 per power 13, and y is equal to 7 root 2 plus 9 per power 9 if t denotes the greatest integer less than equal to t, then the options were, this is odd but GIF of y is even, B, GIF of x and y are both odd, GIF of x plus GIF of y is even, and D, GIF of x is even but GIF of y is odd. So this was the question, and here are the options. how do we proceed in this? Now x is equal to 8 root 3 plus 13, okay, and power is 13. Obviously this is an odd power, and odd power, if you remember, we subtracted. Now why do we subtract? To remove surds. So if we want to remove the surds, we will see. Now let's say x is equal to 8 root 3 plus 13 per power 13, and that is equal to I plus f, where I can be considered as GIF of x, f can be considered fractional part of x, which is written in this way in the standard form. Now we obviously know this fractional part is always belonging from 0 to 1. So again, let's consider x dash is equal to 8 root 3 minus 13 per power 13 is equal to f dash. Now where suppose this f dash belongs from 0 to 1. Why so? Root 3 is 1.7, so 8 into 1.7 is approximately 17.8. It's 152. So if it's 1142, 17 into 8 will be approximately 856. Yeah, it will be 5 13 136. So 136 matlab 13.6 approximately, so it will be greater than 0, positive. Now obviously power n is equal to 13 is odd. Now previously I have done the expansion and then added or subtracted, but here it is odd. I'll directly subtract. So if I subtract x minus x dash, what I will get? I will get it as twice of which power will I get? 13c1 and 8 root 3 per power 12, and this will be 13 per power 1, again plus 13c3 8 root 3 per power 10 and 13 ka cube. So we'll get on like this. So I plus f minus f dash. Now again f minus f dash, I said when I subtract, the value will be equal to 0. Why? Again f minus f dash will always lie from -1 to 1. So what is the integer? Now left hand side is integer, right hand side must be integer, where I is always an integer. So f minus f dash obviously has to be integer, which is equal to 0. So this will be equal to 0. So I is what? Even integer. I is even integer. What is I? I is fractional part of x, which is even. Similarly, what was the question? The question said y is equal to 7 root 2 plus 9. So y is equal to 7 root 2 plus 9 per power 9, which is equal to I plus f, where I can be written as GIF of y plus fractional part of y, which is obviously equal to fractional part of y will always lie from 0 to 1. So in this case, what will I consider? Y dash 7 root 2 minus 9 per power 9, which I can say that it is greater than 0. Why? What is root 2? Root 2 is 1.4. 1.4 into 7 is 10.8. 10.8 minus 9 will be 1.8. So obviously, no, 7 into 1.4, 14 into 7 will be 9.8. 9.8 minus 9, that will be 0.8. 0.8 per power 9 will obviously be positive value, but it will always be less than 1. So it always lies from 0 to 1. So obviously f dash lies from 0 to 1. Now again n is equal to 9, odd. So what we are gonna consider? Y minus y dash is equal to 2 into something. So what this something will be? 9c1 7 root 2 per power 8 into 9 per power 1 plus 9c3 7 root 2 per power 6, and obviously it will be 9 per power 3 and goes on. So which is equal to I plus f minus f dash. Now again this will be 0, so obviously I is even, therefore this will be even. Now according to the question, it asked this is odd but this is even. No, both of them are even. No, so this will obviously be wrong. This will be true. If this is even, this is even, the sum will be even. So D is obviously wrong. Now this was an easy question. Next, now another question says, suppose r is equal to 6 root 6 plus 14 per power 2n plus 1. F is equal to r minus r, that is f is the fractional part. So r minus integer of r, where this denotes GIF function, that is greatest integer function. So what we are required to find? We are required to find r into f, where n belongs to natural number. So obviously we can go by the longer way, but I will tell you the shortcut. Simply, for n belonging to integer, 2n plus 1 will be odd. 2n plus 1 is odd. So remember, we have to do what? We are required to subtract. So if we are required to subtract, then remember f is equal to f dash will be there. So therefore what they are asking r into f shall be equal to r into f dash. Now if r is this which is equal to I plus f, then what is f dash equal to? So what we used to do, we used to write 6 root 6 minus 14 per power 2n plus 1. So r into f dash will be equal to 6 root 6 plus 14 per power 2n plus 1 into 6 root 6 minus 14 per power 2n plus 1. So this is equal to 216 minus 196 per power 2n plus 1. So this is 20 per power 2n plus 1. Now again, next question. Question says x is equal to 8 plus 3 root 7 per power n belongs to natural number. Prove that x minus x square plus x GIF of x is equal to 1. They can ask for, in MCQ, they can ask what is the value of x minus x square plus x GIF of x, but we have to prove. Obviously it's the same way, and this stands as GIF. This is equal to GIF. So how do we prove it? Now again, x is given 8 plus 3 root 7 per power n. Now we'll say let 8 plus 3 root 7 per power n is equal to I plus f. So therefore 8 minus 3 root 7 per power n is equal to f dash, where f is from 0 to 1. So f dash will obviously from 0 to 1. Now what will we do here? And we don't know whether it is even or odd, but we obviously can expand it. How do we expand it? nc0 8 per power n plus nc1 3 root 7 into 8 per power n minus 1 plus it goes on, that will be equal to I plus f. nc0 8 per power n minus nc1 3 root 7 per power 8 per power n minus 1 plus something, that is equal to f dash. Now obviously there can be one thing, add this two up. Why? Because we want it to be surd free. So this will be 2nc0 8 per power n plus nc2 8 per power n minus 2 3 root 7 का whole square plus something something. This is equal to I plus f dash. Now if I say f plus f dash obviously has to be from 0 to 2. Now why? Add this two up. So if it has to be from 0 to 2 and left hand side is an even integer, I is an integer, so f plus f dash must be integer, therefore f plus f dash must be equal to 1. So here the value will be f dash is equal to 1 minus f. Now what we are required to prove? We are required to find x minus x square plus x GIF of x. X minus x square plus x GIF of x. So we can do one thing, x, we can take x common, so what is left out? X minus GIF of x, so which is equal to x minus fractional part of x. Again x common, so this will be fractional part, which is x into 1 minus f. Why? Because we have considered fractional part as f. Now if 1 minus f is there, it can be written as x into f dash. Now what was x? This is x. So what is f dash? We have already written it here. So multiply this two. So this will be 8 plus 3 root 7 into 8 minus 3 root 7 per power n will be equal to x f dash. So 8 is 64, 64 minus 9 into 7, that is 63 per power n, that is equal to 1 per power n, which is equal to 1. And this was what we were required to prove. Done. Now again, next question. It says in this series we will basically be looking at the questions which come from this part, and I will be doing all those questions. So if you look at my video, you solve each of the question, you will not be required to take further help from anywhere in this topic. So see, the question says let p is equal to 2 plus root 3 per power 5, where f is equal to p minus GIF of p, where obviously this denotes GIF, this denotes GIF. What we are required to do? Find value of f square by 1 minus f. So this is the value that we are seeking for. Now see here, to find this value, what we are given? We are given p, and whenever this is given, so 2 plus root 3, root 3 is 1.7. So we obviously have to consider f dash, which is 2 minus root 3 per power 5, and then expand along to find the integral value. Matlab, what is the objective by looking at this? We can find the integral value of this, and then we can manipulate sum of the value to get 1 minus f. Then f square by 1 minus f can be found out. So let's see how do we proceed. P is given as 2 plus root 3 per power 5, which is obviously equal to I plus f, where I is fractional part of p, this is GIF of p. I is integral part of p and f is fractional part of p. Okay, so what we are required to consider? 2 minus root 3 per power 5 is equal to f dash. Add this two up. Why we are adding up? With the previous question, you can look at the previous question. Why do we add up? So this will become obviously 5c0 2 per power 5 plus 5c2 2 per power 3 root 3 का square plus 5c4 2 per power 1 root 3 per power 4, which is equal to I plus f dash. Now from this many questions, we have already got to know f plus f dash is equal to 1. Now we expand. 5c0 is 1, so 2 to the power 5 is 32. 5c2 is 5 into 4 divided by 2. 2 का cube is 8. Root 3 का square will be 3. 5c4 is equal to 5c1, which is equal to 5 into 2. Root 3 per power 4 can be written as 9, which is equal to I plus 1. Now this gets cancelled, so the value is 8 into 3 24 into 10 240. So 32 plus 240 plus 9 into 5, that is 90, is equal to I plus 1. So 240 plus 90 will be equal to 330, 330, 362. 362 into 2 will be equal to 724 minus 1, which is equal to I. So we got the value of integer, that is p, as 723. Now apart from this, if we multiply this equation 1 and 2, what do we get? We get 2 plus root 3 per power 5 into 2 minus root 3 per power 5 is equal to I plus f into f dash. Now we obviously know f dash is equal to 1 minus f. So this will be I plus f into 1 minus f, which is equal to 1. Now therefore the value of I can be written as 1 by 1 minus f is equal to I. So therefore 1 minus f plus f square by 1 minus f is equal to I. So therefore f square by 1 minus f is equal to I minus 1. Why? Separate this 1 minus f by 1 minus f, which will be equal to 1. So therefore f square by 1 minus f will be equal to 7. What was the value of I? 723. 723 minus 1, which is equal to 722. So the value of this will be 722. Last question of this topic is the integer just above root 3 plus 1 per power 2n is for all n belonging to natural number a divisible by 2 to the power n, divisible by 2 per power n, divisible by 2 per power n plus 1, c that is divisible by 8, d divisible by 16. Now this obviously is a nice question where divisibility as well as the integral part of binomial both are involved. Now how do we proceed with this question? Let's see what we are given, root 3 plus 1 per power 2n. So how do we write it as root 3 plus 1 per power 2n? Now can we take 2 inside? We can take it as, so it will become root 3 plus 1 ka whole square per power n, which is equal to 3 plus 1 plus 2 root 3 per power n, and this is equal to 4 plus 2 root 3 per power n. Now we can take 2 common, so it will be 2 per power n, 2 plus root 3 per power n. Now what do we consider this as? We consider let 2 per power n, 2 plus root 3 per power n is equal to I plus f. So we know root 3 minus 1. Now 2 plus root 3 is there, so obviously here it is root 3 plus 1. Now this is equal to this, and which is equal to I plus f. Now root 3 minus 1, which is 1.7 minus 1, that is equal to 0.7, will obviously be greater than 0. So what we will consider? Root 3 minus 1 per power 2n will be equal to, let's say, f dash. Now what are the things? F lies from 0 to 1. Similarly f dash will lie from 0 to 1. Now therefore root 3 minus 1 per power 2n will be written as 4. Why? Again 2 take inside, 4 minus 2 root 3 per power n will be equal to what? 2 to the power n, 2 minus root 3 per power n, which is equal to f dash. Now how do we proceed? We usually proceed in this way. It is I plus f, this is first equation, this is second equation. We used to expand and then add up. Why? The reason being, remove the surds. So if we add these two up, we'll get root 3 plus 1 per power 2n plus root 3 minus 1 per power 2n is equal to I plus f dash, where f plus f dash will be equal to 1. We can see from previous question, or you can say f lies from 0 to 1 and f dash lies from 0 to 1. So f plus f dash will lie from 0 to 2. 0 not included. 0 not included. Done. Now if this is the case, so f plus f dash is equal to 1. Therefore we can say this was 2 to the power n, 2 plus root 3 per power n. So this will obviously be 2 to the power n, 2 minus root 3 per power n, which is equal to I plus 1. Now take 2 to the power n common, and if I add these two up, what are the terms that we will get? 2 into nc0, 2 to the power n, plus nc2. nc2, we can put a small bracket over here. So this will be nc2, 2 to the power n minus 2 root 3 ka square, plus it goes on. So this will be equal to I plus 1. Now let's say this has some integer. So what will be the value? 2 to the power n plus 1 into k is equal to I plus 1. K is some positive integer. K is some positive integer. Now what was the question? The question was the integer just above this. Now this has some integral part I, so the integer just above this will be I plus 1, whose value we have find out. I plus 1 is equal to 2 to the power n plus 1 into k. So obviously this is divisible by 2 to the power n plus 1. Now we check the condition. What were the options? Divisible by 2 to the power n. If it is divisible by 2 to the power n plus n1, it obviously will be divisible by 2 to the power n. So this is correct. This is correct. Now divisible by 8 or divisible by 16. How do we check it out? Let's see. See here. If I put on the condition the I plus 1 is equal to, let's say for n is equal to 1, if I am checking 2 to the power 1 into 2 plus root 3 per power 1 plus 2 minus root 3 per power 1. Which equation did we put on? We put on this equation. So this will be 2 into 4, which is equal to 8. Now I plus 1 is divisible by 8 for n is equal to 1 and is not divisible by 16. Not divisible by 16. So what we are seeking? We are seeking the general case. If we are seeking the general case, we obviously have to remove this option, but this is correct. So this was a nice question, and that's the end of this topic. If you like it, please subscribe. More topics will be coming through. Thank you.